The granite formation called Muradi Rög, which lies beneath the Tolna valleys, formed about 340 million years ago in the Carboniferous period. It is about 25-30 kilometers in width and 200 kilometers in length. In this rock, the National Radioactive Waste Repository was built on the border of Bátaapáti at a depth of 250 meters. The atomic law of Hungary declares that in any nuclear application, safety takes priority before any other considerations, and that the costs of nuclear waste management and the decommissioning of the nuclear power plant shall be covered by those who produce such wastes. The excavation works for the waste repository commenced in 2005. In 2012, as the first two waste disposal chambers were completed, the waste repository was officially commissioned and the first waste container was placed in its final location. In nearly 5 years, the first chamber was filled to full capacity. Parallel to loading the first chamber with waste packages, the structural works of the second chamber continued. A new storage concept was developed for the second chamber. Let us take a look at the differences between the two storage concepts and why the change was necessary. In both cases, the nuclear waste to be disposed is categorized as low and intermediate level waste, which practically means personal, protective equipment and tools contaminated at the nuclear power plant. In accordance with the storage concept applied in the first chamber, Puram employees received the 200-liter waste drums at the site of the nuclear power plant. After strict inspections and registration, each time 16 waste drums were transported in a special vehicle on the M6 motorway to Bátaapáti. The waste drums temporarily stored in the Surface Technological Building were placed in ferro-concrete containers in groups of 9, the space around the drums filled with cement mixture. After a 7-day resting period, the prepared waste containers were transported to the first storage chamber, where a special forklift placed them in their final place. By the time the first chamber was filled up, 4,833 drums in 537 concrete containers were safely disposed of under the ground. In accordance with the new disposal method, the ferro-concrete containers were replaced with so-called compact waste packages, which are prepared at the Paks nuclear power plant. 4 200-liter metal drums are placed in a slim but reinforced steel container. The space around the drums is also filled, but in this case with a special cement mixture that contains liquid radioactive waste. With this solution, the space around the waste drums is also utilized for radioactive waste disposal. After stringent inspection by Puram, these steel container packages are transported 4 at a time to Bátaapáti on the same route. The new waste packages required a redesigned storage chamber. The steel containers, as opposed to the technology used in the first chamber, are housed in a ferro-concrete basin. With minor modifications, the existing forklift can be used for the placement of the new waste packages. The second chamber is filled gradually, with concrete retaining walls installed at around every 19 meters. The space around the containers is filled with cement mixture. Ferro-concrete slabs are also used to cover the basin. In order to utilize the space even better, waste drums are placed atop the covered basin. This space is also filled with cement mixture at every 4 meters. the process is repeated until the whole chamber is loaded and finally closed off with another reinforced concrete wall. With the first technology, only 20% of storage area could contain radioactive waste effectively. The new concept increases this to nearly 50%, resulting in significantly better space utilization and consequently reduced costs. The first chamber is filled completely. Now the second chamber awaits the new waste packages. The mining of chambers 3 and 4 has been completed. 2 additional chambers will be developed in the coming years, increasing the storage capacity to 20,000 cubic meters. This space shall be sufficient not only for disposing of the waste generated during the operational lifetime of the existing nuclear power plant units, but also for waste generated during decommissioning. Continuous monitoring at several sites at and around the facility ensures a high level of safety. The Moorite granite rock formation isolates the disposal area from surface processes and human activities, protects the biosphere from radioactive materials, and completely retains short-lived radionuclides. The efficiency of the project is internationally renowned. The safety of our future, the responsibility of our present.